Hello, my dear students. This is Hina Kausar, and welcome back to the class. In the previous session, we were discussing about numericals, right? We had solved few numericals following simple steps. Now let's continue our discussion and solve few more numericals on the chapter electric charges. And so the next question is 4-point charges. QA is equals to 2 microcoulombs, QB is equals to minus 5 microcoulombs, QC is equals to 2 microcoulomb, QD is equals to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. Full stop. What is the force on a charge of 1 microcoulomb placed at the center of the square? Okay. Let's understand this question sentence by sentence. Okay. So what does the first sentence mean? 4-point charges. ಅಂದ್ರೆ 4 point charges ಕೊಟ್ಟಿದ್ದಾರೆ. Each charge value is given in terms of microcoulombs. Okay, and they have given the notation for each charge as QA, QB, QC, and QD. And all these charges are located at the corners of a square. What does this mean? It means we have to imagine a square such that at each vertex of the square, okay, at each vertex of the square, we have to place these charges. Let us imagine this is the square which we are talking about, that is A, B, C, D, and at each corner of this square we have placed these charges. At corner A, the charge QA is equals to 2 microcoulomb. At corner B, the charge QB is equals to minus 5 microcoulomb, and at vertex C, the charges QC is equals to 2 microcoulomb, and at corner D, its QD is equals to minus 5 microcoulomb. And they have also mentioned the side, the square side length value they have given, that is centimeter. And the square and each one side in the length idre, that is the same value it has for all the sides of the square. So the value they have given for the side is 10 centimeter. It's understood that the other sides of the square will also have the same value. So that's the meaning of the first sentence. That is what we have to imagine pictorially. Okay. So the next part of the question is, what is the force? See, directly they have asked you to determine what is the force. Electrostatic force now calculate ಮಾಡಬೇಕು. Where we have to calculate the force on a charge of 1 microcoulomb placed at the center of the square. Okay. It means for the square we should construct a center where we will place this 1 microcoulomb of charge. Okay. How can we get a center for the square? If we draw two diagonals, so that will cross each other, and that intersection point we can consider it as the center of the square. So we have to imagine that at the center one charge has been placed and the value of the charge is 1 microcoulomb. So what is the total force, or what is the net force which is acting on this charge? That has to be calculated due to these charges which are present at the corners of the square. Okay, so let us imagine that the charge which is placed at the center, that as we will take the notation as Q naught. Okay, Q naught has the charge value as 1 microcoulomb. Okay, I hope you understood the question. So according to the question, we have interpreted what is given. So looking at the present situation, which formula will help us to determine the force? Obviously, it will be the Coulomb's law, right? Because that is the equation which will give us the value for force, right? So to calculate the force, let us see individually each charge, how it is acting the force on this charge which is placed at the center. Okay. So say first, for example, at the corner A, we have placed the charge QA. So this charge, what will be the force exerted on this charge at the center Q naught? Obviously, it can be given by the Coulomb's law, that is FA is equals to 1 over 4 pi epsilon naught. Instead of taking Q1 and Q2, we should mention it as QA and Q naught, because the first charge which we are considering is the charge which is placed at the corner A, and the second charge which we are considering is the charge which is lying in the center. So therefore, instead of Q1 and Q2, we should take it as QA and Q0 divided by X square. X I am taking it because I am assuming that the distance between the center and the corner of the square is X. Okay, that's distance between the two charges. So this distance, half of the diagonal, that distance I have mentioned it as X. So this will be the force which will be acting on the center charge, that is Q0, which is due to the charge placed at A. And what will be the direction on this? This will be the magnitude. What about the direction of this force? Obviously, it will be along OC, right? Why it will be along OC? Because the charge which is placed at this corner A, if you observe, it is having a positive polarity, right? It is a positive charge that is mentioned, plus 2 microcoulombs, right? And the charge is placed at the center, that is also a positive charge, right? And we know according to the theory that the force between any two same kind of charges, that is positive or negative charges, force of repulsion. Therefore, the force will act away from the charge. Therefore, the direction of the force which will be acting between the charge placed at A and at the center, it will be away from the charge, away from the center. Therefore, it will be acting along OC. Okay, so this is about the charge due to the first corner, that is A. And what about the charge which is placed at C? Okay, since this is the single diagonal, I will take this corner. That is the force which is acting on the center of the charge placed at the center due to the charge C. Again, we will take it according to the Coulomb's law, that is 1/4 pi epsilon naught. Instead of Q1 and Q2, we should now consider the charge placed at corner C, that is QC, and charge placed at the center, that is Q0. So QC by Q0 divided by X square. X will be the distance between the center charge and the charge which is placed at the corner C, right? So this will be the magnitude of the force. But what about the direction? Direction, if you see again, this charge which is placed at the corner is also of positive polarity, right? And in the center, it is also having the same positive charge. Therefore, the nature of the force which will act between these two charges, that will be of repulsion. Therefore, the direction we will show, the direction will be away from this charge. That is, FC will be acting along OA, right, in this direction. Okay. If you observe the diagram, what you can see, since this charge QA, what is the magnitude of this charge? That is 2 microcoulomb, right? And what about the charge QC? That is also 2 microcoulomb, right? Since these two charges are of same magnitude, then what about the magnitude of the forces which will act on this center charge? That will also be same, right? Since the magnitude of the charges are equal, therefore the forces which is exerted due to these charges will also be equal. What about the direction? If you observe the direction, both the forces are acting in opposite direction. One ಕೆಳಗಡೆ direction ಅಲ್ಲಿ ಇದೆ along OC. ಮತ್ತೊಂದು force ಏನಾಗಿದೆ? It is along OA direction. Both the force direction are opposite in nature. Therefore, what happens? Since the forces are of equal magnitude and in opposite direction, then the net force at the center will be 0 because these two forces will cancel each other. Isn't it? ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು? ಎರಡೂ ಫೋರ್ಸ್, ಈ ಚಾರ್ಜ್ ಎ ಮತ್ತೆ ಚಾರ್ಜ್ ಸಿ ಇಂದ ಈ ಸೆಂಟರ್ ಚಾರ್ಜ್ ಮೇಲೆ ಎಕ್ಸರ್ಟ್ ಆಗ್ತಿರೋದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನಾಗಿರುತ್ತೆ? ಸೇಮ್ ಇರುತ್ತೆ. ಯಾಕೆ ಸೇಮ್ ಇರುತ್ತೆ? ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಆಗಿರ್ತಕ್ಕಂಥ ಚಾರ್ಜ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಸಿ ಹತ್ರ ಪ್ಲೇಸ್ ಆಗಿರ್ತಕ್ಕಂಥ ಚಾರ್ಜ್ ವ್ಯಾಲ್ಯೂ ಎರಡೂ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಏನಿದೆ ಈಕ್ವಲ್ ಇದೆ. ಹಾಗಾಗಿ ಅದು ಎರಡೂ ಚಾರ್ಜಸ್ ಕೂಡ ಈಕ್ವಲ್ ಆಗಿ ಈ ಸೆಂಟರ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಚಾರ್ಜ್ ಮೇಲೆ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡುತ್ತೆ. ಬಟ್ ಡೈರೆಕ್ಷನ್ ಏನಾಗಿದೆ? ಎರಡರಿಂದು ಡೈರೆಕ್ಷನ್ ಆಪೋಸಿಟ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಎರಡು ಫೋರ್ಸಸ್ ಏನಾಗುತ್ತೆ? ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಈ ಎರಡು ಚಾರ್ಜಸ್ ಇಂದ ಈ ಸೆಂಟರ್ ಚಾರ್ಜ್ ಮೇಲೆ ಎಕ್ಸರ್ಟ್ ಆಗ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. ಓಕೆ, ಫೈನ್. Then what about the force which will be exerted on the center of the charge? So it will be due to the remaining two charges which are at the other two corners of the square, right? So let's see if those two charges exert any force on the central charge. Fine. So now look at the magnitude of the force which is due to this charge which is placed at B. Okay, again we will consider the Coulomb's law. That is, according to Coulomb's law, the force due to the charge placed at B will be equal to 1 over 4 pi epsilon naught QB Q naught divided by x square, right? Why we have to QB Q naught? Because we are considering the charge placed at point B and the charge which is placed at the center. So QB and Q naught. X is the distance between these two charges. I have imagined this half of the distance is x. So that will be the magnitude. What about the direction? So observe the magnitude of the charge which is placed at corner B. Magnitude of the charge placed at B is minus 5 microcoulomb. It is a negative polarity, negative charge, right? Centrally ಇರ್ತಕ್ಕಂಥದ್ದು positive charge 1 microcoulomb. So negative ಮತ್ತೆ positive ಇದ್ರೆ, unlike charges ಇದ್ರೆ, what kind of force, electrostatic force we will observe? It will be electrostatic force of attraction. Since it is force of attraction, we can say that the force exerted due to the charge QB to the charge Q naught, it will be attractive in nature. So direction will be acting, which will be towards the negative charge, right? So force of repulsion idre away from the positive charge irutte. Force of attraction idre towards the negative charge irutte. So here the force will be acting along O to B. So FB force is acting from O to B. Similarly, if we say about the force which is due to the charge placed at D on the charge which is placed in the center Q naught, right, center O, then according to Coulomb's law, it can be given as FD is equals to 1 over 4 pi epsilon naught QD Q naught divided by x square. So QD is the charge placed at corner D, Q naught is the charge placed at the center, x is the distance between these two charges. This will be the magnitude. And direction is, since the charge which is placed at the corner D is negative and the charge which is placed at the center is positive, force of attraction irutte. Force of attraction idre direction yav riti irutte, force will be always acting towards the negative charge. Therefore, here in this case, it will be along O to D. And again, if you see, the charges which are placed at B, corner B and corner D are having equal magnitude. Illu kuda minus 5 microcoulomb ide, illu kuda minus 5 microcoulomb ide. Andre meaning eno, the magnitude of the forces will also be same, right? If the magnitude of the forces is same, what about the direction? If you observe the direction, both the directions are in opposite direction, right? Magnitude same ಆಗಿದ್ದು opposite direction ಅಲ್ಲಿ forces act ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ they will cancel each other. Therefore, the net force which will be acting at the center will be equal to 0, right? ಅಂದ್ರೆ ಈ diagonal ಅಲ್ಲಿ corners ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂತ charges ಇಂದ ಕೂಡ ಈ force ಏನಾಗುತ್ತೆ, ಈ center charge ಮೇಲೆ 0 ಆಗುತ್ತೆ. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಎರಡು ಚಾರ್ಜಸ್ ಈಕ್ವಲ್ ಆಗಿ ಫೋರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆ, ಬಟ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ. ಇಫ್ ಯು ವಾಂಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್ ಮೋರ್ ಪ್ರಿಸೈಸ್ಲಿ, ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಟಗ್ ಆಫ್ ವಾರ್. ಟಗ್ ಆಫ್ ವಾರ್ ಗೇಮ್ ನೀವು ಆಡಿರ್ತೀರಾ ಮೋಸ್ಟ್ ಆಫ್ ಆಲ್. ಒಂದು ರೋಪ್ ಅಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಕ್ಲಾತ್ ನ ಕಟ್ ಹಾಕಿ ಎರಡು ಸೈಡ್ ಇಂದ ಸ್ಟೂಡೆಂಟ್ಸ್ ಫುಲ್ ಮಾಡ್ತೀರಾ, ರೈಟ್? ಆ ಗೇಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಯಾವ ಕಡೆ ಜಾಸ್ತಿ ನೀವು ಪ್ರೆಷರ್ ಹಾಕ್ತಿರೋ ಆ ಕಡೆ ಆ ಕ್ಲಾತ್ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ದಟ್ ಟೀಮ್ ವಿಲ್ ಬಿ ದ ವಿನ್ನರ್, ರೈಟ್? ಸೊ ಎರಡು ಕಡೆ ಈಕ್ವಲ್ ಆಗಿ ಫೋರ್ಸಸ್ ಇದ್ರೆ ಡಸ್ ದ ಸೆಂಟರ್ ನಾಟ್ ಆರ್ ದ ಸೆಂಟರ್ ಕ್ಲಾತ್ ವಿಲ್ ಮೂವ್ ಅಟ್ ಇದರ್ ಸೈಡ್? ಮೂವ್ ಆಗಲ್ಲ. ಫೋರ್ಸಸ್ ಏನಾಗುತ್ತೆ, ಎರಡು ಕಡೆ ಈಕ್ವಲ್ ಇದ್ರೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ದ ಗೇಮ್ ವಿಲ್ ಬಿ ಟೈ. ಅಂದ್ರೆ net force acting on both the sides will be 0, right? Same situation, instead of tug of war, you just remember this situation, you try to apply the situation here. Here also what happening, since at both the sides forces acting or magnitude is having same, but they are in opposite direction. Therefore net force ಈ ಸೆಂಟರ್ ಮೇಲೆ ಏನಾಗಿರುತ್ತೆ, 0 ಆಗಿರುತ್ತೆ. ಸೊ ಈ ಸೆಂಟರ್ ಚಾರ್ಜ್ ಯಾವ ಕಡೆನೂ ಮೂವ್ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ನೆಟ್ ಫೋರ್ಸ್ ನಾವೇನಂತ ಹೇಳ್ಬೋದು, 0 ಅಂತ ಹೇಳ್ಬೋದು. ಎರಡು ಕೇಸಸ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. ವಿ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಆಲ್ ದ 4 charges now. The net force which is caused due to all these 4 charges which are placed at the corner of the square, uh, uh, it will have no force. It will act no force or 0 force on the center charge, right, which is placed at the center. That is 1 microcoulomb charge ಮೇಲೆ ಯಾವುದೇ ರೀತಿ force experience ಆಗಲ್ಲ. So that is the answer for this question. I hope you understood. So this answers our question. Okay, let's move to the next question. Next question is 2-point charges QA is equals to 3 microcoulomb and QB is equals to minus 3 microcoulomb are located 20 centimeter apart in vacuum. Okay. Now the question has been split in 2 parts and they have asked what is the electric field at the midpoint O of the line AB joining the 2 charges. That is our first question. Second part of the question is, if a negative test charge of magnitude 1.5 into 10 to the power of minus 9 coulomb is placed at this point, what is the force experienced by the test charge? So let's try to imagine this question sentence by sentence. Okay. So first sentence alli question alli ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, they have given us the magnitude of 2-point charges. One magnitude is Q is equals to 3 microcoulomb and one more charge magnitude is QB is equals to minus 3 microcoulomb. Right? Micro means 10 to the power of minus 6. We know that. And these 2 charges are located 20 centimeter apart in vacuum. These 2 charges are placed in vacuum at the distance of 20 centimeter. ಅಂದ್ರೆ ಆ ಎರಡು ಚಾರ್ಜಸ್ ಮಧ್ಯದಲ್ಲಿ ಇರತಕ್ಕಂತ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿದೆ 20 ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಅದು ವ್ಯಾಕ್ಯೂಮ್ ಅಲ್ಲಿ ಇದಾವೆ. ಓಕೆ. ಸೊ ಫಸ್ಟ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನಿದೆ, ಸಿಚುವೇಶನ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ವಾಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಓ ಆಫ್ ದ ಲೈನ್ ಎ ಬಿ ಜಾಯ್ನಿಂಗ್ ದ 2 ಚಾರ್ಜಸ್. ಅಂದ್ರೆ ಎರಡು ಚಾರ್ಜಸ್ ಒಂದು ಲೈನ್ ಮೇಲೆ ಇದೆ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿದ್ರೆ, ಲೆಟ್ ಅಸ್ ಅಸ್ಯೂಮ್ ದೇರ್ ಈಸ್ ಅ ಲೈನ್ ಕಾಲ್ಡ್ ಎ ಬಿ. ಒನ್ ಎಂಡ್ ಹತ್ರ ನಾವೇನ್ ಮಾಡಿದೀವಿ, ಚಾರ್ಜ್ ಕ್ಯೂ ಎ ನ ಪ್ಲೇಸ್ ಮಾಡಿದೀವಿ, ದಟ್ ಇಸ್ 3 microcoulomb. You can also write it as 3 into 10 to the power of minus 6 coulomb. Okay na? So second corner alli at the second end of the line we have placed the other charge, that is minus 3 microcoulomb. So its value can be written as minus 3 into 10 to the power of minus 6 coulomb. So distance between ಈ 2 charges ಮಧ್ಯದಲ್ಲಿ distance ಏನಿದೆ ಅಂತ ಹೇಳಿದಾರೆ ಅವರು 20 centimeter. So we have imagined r is equals to 20 centimeter. So distance na ನಾವು r ಅಂತ ತಗೊಂಡಿದ್ದೇವೆ. So that is equals to 20 centimeter. Now in the first part we have to say that at the midpoint O, okay, ಈ midpoint O ಹತ್ರ electric field ಏನಿದೆ that we have to calculate. Okay. So for that we should also consider if we have a midpoint for this line, the distance between the midpoint and the first charge and the midpoint and the second charge, that is AO and AB, will be equal to 0.1 meter, right? So ಈ 20 centimeter na ನಾವು meters ಗೆ convert ಮಾಡ್ಕೊಂಡ್ರೆ we can write it as 0.2 meter, right? And if we divide it into 2 equal halves, distance between O to A, it will be 0.1 meter, and distance between O to B, it will be 0.1 meter. So that is what we have to imagine to answer our first question. Okay. I hope you have understood the scenario. So now to determine what is the electric field, let us imagine. So let us say the electric field which is due to A. What will be the direction of the electric field due to the charge placed at A? Obviously it will be away from this center. Why? Because the charge which is placed at this point A, it is a positive charge, right? Therefore, the electric field will be acting away from the positive charge. So it will be acting from O to B. Okay. Because we know that electric field always for a point positive charge, it will be acting radially in outward direction. So it will be acting from O to B. Similarly, the electric field, if we consider, which is due to the charge placed at B, what will be the direction of that electric field? If we assume vector EB as the electric field, its direction will be from O to B, right? Why it will be O to B? Because the charge is placed at B is a negative charge, and we know the direction for a negative charge, negative point charge will be always acting radially in inward direction. Therefore, the electric field due to both the charges, direction is along O to B. So that I have mentioned in sentence here. Distance between the two charges, AB is equals to 20 centimeter. Therefore, AO is equals to 10 centimeter and OB is equals to 10 centimeter. So 10 centimeter can be written in terms of meter as 0.1 meter. And the net electric field at point O will be caused due to plus 3 microcoulomb. Direction ಬಗ್ಗೆ ನಾನು ಇಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. What about the magnitude? Obviously, magnitude formula we know. The electric field due to any point charge can be given by 1 over 4 pi epsilon naught Q divided by R square. That is the formula. But in place of Q here, we should take it as QA because that is the charge it is placed at point A, right? ಆ charge in the electric field produce ಆಗ್ತಾ ಇದೆ. So ಹಾಗಾಗಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? QA ಅಂತ consider ಮಾಡ್ತೀವಿ divided by what is the distance between those two charges? Distance is OA, right? Or AO. So instead of writing R square, we should mention it as AO square. And what about the direction? Direction, as I said, since it is a positive charge, electric field will be acting in radially outward direction. So it will be along O to B. So this is the magnitude of the electric field, which is due to the charge placed at A. That is due to 3 microcoulomb. Plus 3 microcoulomb ಇಂದ ಈ ಪಾಯಿಂಟ್ ಮಿಡ್ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳ್ಬೇಕಂದ್ರೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಈ ಈಕ್ವೇಶನ್ ಇಂದ ಹೇಳ್ತೀವಿ. ಡೈರೆಕ್ಷನ್ ಏನಾಗಿರುತ್ತೆ? O to B ಇರುತ್ತೆ. Similarly, now ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್. ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಗಿದೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇಂದು, ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಹಾಗಾಗಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ವ್ಯಾಲ್ಯೂಸ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಡಿಟರ್ಮೈನ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ. ಚಾರ್ಜ್ QA ವ್ಯಾಲ್ಯೂ ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ದಟ್ ಇಸ್ 3 microcoulomb. ಸೊ ಹಾಗಾಗಿ 3 microcoulomb ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ QA we will substitute it as 3 into 10 to the power of minus 6. AO square ಅಂದ್ರೆ the distance between O to A, that we have took it as 0.1 meter. So we will substitute it as 0.1 whole square. So 1 over 4 pi epsilon naught value ಗೊತ್ತಿದೆ ನಮಗೆ, that is 9 into 10 to the power of 9. ಆ ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂಸ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಏನ್ ಸಿಗುತ್ತೋ, so that will be the magnitude of the electric field, which is due to the charge A on the midpoint. Okay, and it will be in terms of Newton per coulomb, and its direction will be from O to B. Right? Now let's see similarly what will be the electric field, magnitude of the electric field due to the charge placed at B on the midpoint O. ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ B ಹತ್ರ, ಎಂಡ್ B ಹತ್ರ ಪ್ಲೇಸ್ ಮಾಡಿರ್ತಕ್ಕಂಥ ಚಾರ್ಜ್ QB ಇದೆಯಲ್ಲ, -3 microcoulomb ಇಂದ ಅಲ್ಲಿಂದ ಆ ಚಾರ್ಜ್ ಇಂದ ಈ ಮಿಡ್ ಪಾಯಿಂಟ್ ಮೇಲೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿದೆ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಅಗೇನ್ ವಿ ನೋ ದ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ. ಫಾರ್ಮುಲಾ ಏನು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಗೆ? EB is equals to 1 over 4 pi epsilon naught QB divided by OB square. QB ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಚಾರ್ಜ್ ಪ್ಲೇಸ್ಡ್ ಅಟ್ ಪಾಯಿಂಟ್ B is QB. therefore we will take the formula as QB. ಮತ್ತೆ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿದೆ ಮಿಡ್ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಆ ಚಾರ್ಜ್ ಮಧ್ಯದಲ್ಲಿ, that is OB or BO, right? That is nothing but 0.1 meter. So ಹಾಗಾಗಿ ನಾವು ಇಲ್ಲಿ ಏನ್ ತಗೊಳ್ತೀವಿ? OB square ಅಂತ ತಗೊಳ್ತೀವಿ. Direction again it is along OB. Why? Because the charge placed at B is a negative charge. Therefore, the direction of electric field will be acting towards it, right? After substituting the value, what we will get? EB is equals to 1 over 4 pi epsilon naught. Magnitude of the charge, they have given it as 3 into 10 to the power of minus 6. So we will write that one, divided by 0.1 whole square, because that is the distance between the charge and the midpoint. Okay. If you observe both these equations, right? So equation, that is electric field due to the charge at A, this value, right? And the electric field due to the charge placed at point B. Both the values are same, right? Magnitude of electric field due to the charge A and the magnitude of electric field due to the charge B, both are equal, right? ಎರಡು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಈಕ್ವಲ್ ಆಗಿರೋದ್ರಿಂದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಹತ್ರ ಏನಾಗಿರುತ್ತೆ, ಆಬ್ವಿಯಸ್ಲಿ at the midpoint the total electric field will be the sum of these two electric fields due to charge A and charge B. Therefore electric field at midpoint O will be equal to EA plus EB ಅಂತ ತಗೊಳ್ತೀವಿ. ಎರಡರಿಂದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಆಡಿಂಗ್ we can write it as 2 into EA, right? EA plus EB ಅಂತ ಬರೆಯೋದು ಒಂದೇ. EA is equals to EB ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ ಅಲ್ವಾ, ಸೊ ಹಾಗಾಗಿ ನಾವು 2 EA ಅಂತ ಬರಿಬಹುದು. ಓಕೆನಾ? EB ನ ರಿಪ್ಲೇಸ್ ಮಾಡಿ EA ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ EA plus EA becomes 2EA ಹಾಗಾದ್ರೂ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಅಥವಾ simply it is multiplied by 2 twice because magnitudes are same, right? So 2 into magnitude of EA we know, that is 1 over 4 pi epsilon naught, 3 into 10 to the power of minus 6 divided by 0.1 whole square. So substitution ಮಾಡಿ 1 over 4 pi epsilon naught value 9 into 10 to the power of 9 substitution ಮಾಡಿ, instead of 0.1 whole square we can write it as 10 to the power of minus 1 whole square. So 10 to the power of minus 1 whole square becomes 10 to the power of minus 2. Further simplifying it, whole numbers na separate ಆಗಿ multiply ಮಾಡ್ಕೊಳ್ಳಿ. 2 into 9 into 3 gives 54, 10 to the power of 9 as it is. 10 to the power of minus 2 numerator ಹೋದ್ರೆ it becomes minus 6 minus 2 becomes minus 6 plus 2 becomes minus 4. Further simplifying, 9 minus 4 becomes plus 6. Okay, so 9 minus 4 becomes plus 5. If we take a decimal to the left, the decimal power, exponential power becomes 10 to the power of 6 Newton per Coulomb. So the value of electric field will be 5.4 into 10 to the power of 6 Newton per Coulomb, right? So that will be the electric field which will be experienced at the midpoint O due to the charges which are placed at corner A and corner B. So that answers our first part of the question. Okay, so the remaining second part of the question we will discuss it in the next class and try to find out what will be the solution. Okay.